Okay guys, so in this video we're looking at probability functional skills and it's a lesson for your preparation for your NCFE examination. Okay, so this will be hopefully lesson 7 at the time of recording this. Okay, so this is your starter guys. Okay, so pause the video, have a go at the question or questions, and then press play when you're ready to see the answers. Okay. So answers for these. Question number 1. List all the factors of 10. So factors are numbers that go into 10, okay, without a remainder. That's 1, 2, 5, and 10, okay? These are the 4 numbers that, okay, that go into 10 with 0 remainder. So 1, 2, 5, and 10. Okay. This is question number 2. Write 8 times 10 to the 3 or 8 times 10 cubed as an ordinary number. So 10 cubed means 10 times 10 times 10, which is 1,000. So it's 8 times 1,000 or 8 multiplied by 1,000, which is equal to 8,000, guys. Okay, this is question number 3. Find 50% of 10. So 50% of any quantity, I divide it by 2. So 10 divided by 2, okay, I half 10, which is equal to 5. Okay, think of it as 100% is equal to 10. Okay, 50% is equal to a half of 10, which is 5. Question number 4. Find the mode of these data, okay, or these words. Okay, chocolate bar, rubber, ruler, rubber. So rubber appears twice, so rubber is the mode. Okay, so the word mode means most occurring or most frequent. Okay, so the answer is rubber because rubber appears twice, whilst ruler and chocolate bar only appear once, okay, consecutively. Question number 5. Write 900 in standard form. Start with the same as saying 9 times 10 to the power of 2. So it's a number between 1 and 10 times 10 to the power of something. So that'll be 9, okay, 9.0 or 9 times 10 to the power of 2. 9 times 10 squared, okay. 10 squared, remember, means 10 times 10, okay, which is 100. 9 lots of 100 is equal to 900, okay. 9 times 100 is equal to 900. Question number 6. How many sides does a triangle have? A triangle has 3 sides, okay. So this is what a triangle looks like, okay. It has 3 sides. Question number 7. Simplify 2 to the power of 3 times 2 to the power of 1. So 2 cubed times 2 to the 1. If it has the same base and I'm multiplying, I just add the powers. So I have 2 to the 3 plus 1, which is equal to 2 to the 4. So 2 to the power of 4, guys. This next one, question number 8. 4 times 4 divided by 2. So using BIDMAS, I'm going to do the division first. So 4 divided by 2 is 2. So 4 lots of 2. So 4 times 2, okay, because this answer gives me the number 2. So then I have 4 times 2, 4 lots of 2, which is 8, guys. Okay, so you're always following BIDMAS. Okay, remember BIDMAS when you have order of operations. Okay, when you have multiple operations in any given sum. Okay. Brackets, indices, division, multiplication, addition, and subtraction. Question number 9. Simplify 9/15. Well, the highest common factor is equal to 3. So divide top and bottom by 3, and I get 3/5. Okay. These are what I call equivalent fractions. Okay. So 3/5, is a fraction in its simplest form. Okay. So dividing top and bottom by 3, guys. Okay. Because 3 is what I call the highest common factor. So the highest number that goes into both 9 and 15 cleanly without a remainder is 3. Okay, so divide top and bottom by 3 and I get 3/5. Question number 10. Convert 10 kilograms to grams. Well, I'm going to times by 1,000. Okay, kilograms to grams, you multiply by 1,000. So 10 times 1,000 is equal to 10,000. Okay, so 1 and then 4 zeros. Okay. And then if you want to put like a comma, just obviously break it up so you can pronounce it obviously clearly. That's your answer for that question. Okay. There are your answers, guys, okay, for this question. Right, so learning outcomes. So today's lesson, we are going to define probability, develop an understanding how to correctly write probability. So how to correctly write probability and calculate probability from examples. Okay, so what is probability? So probability in like short, guys, is the chance of an event occurring or not occurring. So the chance of something happening. So for example, flipping a coin, okay, there is a chance that I'll get a heads and there's a chance that I'll get tails, okay? Rolling a dice or a die, okay? The chance of that, obviously, it's going to obviously be different, okay, for obviously different numbers, okay? But if we class it as like an ordinary die, then it has like equally, like equal and fair outcome. Okay, many events can't be predicted with total certainty. The best we can say is how likely they are to happen using the idea of probability. Okay, so learning outcome 1, define probability. Okay, so key words for probability. Okay, so I've mentioned these here very, very briefly. So certain means it's 100% chance, so something will definitely happen. Okay, likely something isn't certain, but there is a chance that it will happen. Even chance, something is as likely to happen as it is not likely to happen. Unlikely, something isn't impossible, but it probably won't happen. And impossible, there's no chance at all of something happening. Okay, and I'm sure you can all think of some examples here for like certain, likely, even chance, unlikely, impossible. So for example, for certain, it is certain, that if someone's in a job, that they will obviously pay what we call taxes. Okay, so taxes, is obviously certain, for that. Okay, and then other thing. Okay. So this next part, numbers to describe probability. If something is impossible, it has a probability of 0, okay, so 0%. An even chance, the probability of 0.5, half of 50%. Again, so probability can be expressed as a decimal, a fraction, or a percentage. So so that's obviously our decimal. That's our fraction. And that's our percentage, okay, at the end. So probability can be expressed as a decimal, fraction, or a percentage. Okay, so certain equals probability of 1.0 or 1 whole or 100%. Okay, probability is obviously going to be 1. Likely, probability between 0.5 and 1, so the more likely the probability that is closer to 1. Unlikely, the probability between 0.5 and 0 and 0, less likely the closer it is to 0. Okay, so I can write this on like a probability scale. So you got 0 there, 0.25, or a quarter chance, an even chance, so you can toss a coin and land the heads. Okay, so that's obviously even chance, okay, because you've got heads or tails. Okay, Valentine's Day being on the 14th of February, so that's obviously certainly obviously every year. Okay, you can even mention about like obviously like Pie Day or Pancake Day, being on like certain days of the year. So Pie Day, it is always in March. Okay, because pi is so the number pi. Okay, is 3.14. Obviously, actually, so it's always 14th of March. Okay, so that's always certain. Okay, you also got like other days here, so you have like pancake days, let's say. Days. Like for example, you might have like paying taxes. So like that's obviously certain if you're in work. So paying taxes. Okay, and there's lots out there, like that. Okay, like another one could be Christmas being on the 25th of December every year. Okay, so on and so forth. Boxing Day being on 26th. yeah, and so on and so forth. Okay, so yeah, so feel free to obviously pause the video and obviously make your own statements here on some of these. Okay, for 0, okay, obviously it's impossible. Okay, let's say, yeah, so let's say it's a Monday, it's impossible, yeah, obviously tomorrow, yeah, will obviously be like a Sunday. Okay, yeah, if we assume that we're on a Monday, yeah, so like, yeah, so certain things are impossible like that. Okay, yeah, there are other things, yeah, that are obviously impossible, yeah, that I can't actually think of actually right now, but yeah, yeah, for example, actually, yeah, so like, so for example, like at the time of, yeah, of obviously recording this year, obviously lockdown, yeah, and COVID actually, that's already happened. Okay, so 2020, yeah, has happened, so 2020, yeah, will never happen again ever. Okay, or sorry, or will happen again. Okay, that's obviously going to be 0, isn't it? Because yeah, obviously we will never obviously have 2020 again, yeah, in our lifetime. Okay, yeah, because obviously dates, yeah, are always moving forward. Okay, yeah, another one could be, obviously, yeah, that it's impossible to obviously be alive forever. Obviously, yeah, sorry to sound like a bit doom and gloom actually, but yeah, I'm like, if it's obviously, yeah, it's impossible to obviously be alive forever. Okay, yeah, because obviously everything obviously terminates eventually. Okay, yeah, sorry to sound a bit gloom there. I apologise. Okay, yeah, and think of some of the ones here for other like likely and unlikely. Okay, for unlikely, you could say, yeah, it's unlikely to like snow in June. You could say, so snow in June. Okay, because like snow in June, yeah, like in the UK. Yeah, because obviously June is considered like a summer month. And for likely, you could say, yeah, like snow in December, for example. It's unlikely, yeah, that you will roll a 1, yeah, on a 6-sided dice. Okay, for that. Okay, so on and so forth. Okay, again, there are so many out there, yeah, for obviously even chance and all that. So example 1, the following cards are placed in a box. A card is selected at random. Okay, find the probability that the number on the card for part 8 is a number 3, where you've got 1 out of 1, 2, 3, 4, 5, 6. So you've got 1 out of 6 possible outcomes. So 1/6 or 1/6. Okay, part B, an odd number. So an odd number is 1, 3, or 5. So that'll be 3 out of a total possible of 6. Okay, so 3/6, or I can simplify that to 1/2. Okay, either answer will suffice. Okay, but for the purpose of today's video, I'll leave it as 3/6. Okay, just obviously make it clear on where I got my answers from. Okay. So this next one, Thomas has, example 2, Thomas has 12 cards, each with a letter on it. You've got Corbett Maths. He picks a card at random. Write down the probability that the chosen card is a letter H. Well, that would be 1 out of 12. Okay, so 1/12. Okay. For part B, the letter T, well, I've got 1, 2, 3. So I've got 3/12. Okay, which simplifies to 1/4. Okay, but again, the purpose of today is obviously actually working out the actual probability here. So I don't want to see obviously dwelling here on the actual like simplifying. As long as we're happy with how we get the probability, then that's the most important part here for today's lesson. For part C, not the letter E. So there's 1E. So not E will be 11/12. Okay, because the probability of getting an E will be 1/12. So the probability that it's not the letter E is what I call the complementary. So yeah, so it's 1 take away 1/12. Okay, and 1 whole can be written as 12/12. When you work it out, you get 11/12 or 11/12. Okay, for part D, the letter B or the letter T. So it's an OR here. So the OR means an addition. So I've got 1, 2, 3, 4. So it will be 4/12, which simplifies to 1/3. Okay, divide top and bottom by 4. But again, I'll leave my answer as that. Okay, because it didn't actually simplify. Okay, yeah, so I don't want to obviously worry about that. Part E, a vowel. So a vowel is either A, E, I, O, U. Okay, so we got 1 here. We've also got another one. We've also got an O. So we've got 3/12. Okay, which again simplifies to 1/4. But I'll leave my answer as 3/12. Okay. Example 3, Liam rolls an ordinary fair 6-sided dice. Write down the probability that he gets the number 4, where you got the numbers 1, 2, 3, 4, 5, 6. So the probability that I'm going to get a 4 is 1 out of a possible 6. Okay, 6 possible answers, okay, or 6 possible outcomes. So it's 1/6. Okay. For part B, a number less than 5, 1, 2, 3, 4. So you got 1, 2, 3, 4. So the answer will be 4/6 because I can have 4, 3, 2, 1. Okay, so that will give me 4 outcomes out of the total possible of 6, which simplifies to 2/3. Okay, I'll write 4/6 there. Okay. Okay, so calculating probability, yeah. So sometimes you may need to work out the probability of something happening. So yes, so yeah, we've just done a few there. Example: Sam is a hockey club coach. He divides the team of 16 players by asking each player to draw a ticket at random of the hat. The hat contains 4 green, 4 red, 4 blue, and 4 purple. Okay, yeah, it is obviously color coordinated here. What's the probability that the first player picking a blue ticket? Well, that'll be 4 out of 4 plus 4 plus 4 plus 4. So that'll be 16. Okay, if you're not sure, yeah, we'll just do it up here. 4 plus 4 plus 4 plus 4. Okay, so it's equal to 16. So there are 16 possible outcomes. Okay, so yeah, possible of 16 outcomes in total is 4/16, which simplifies to 1/4. Divide top and bottom by 4. So the fraction element is 1/4. Now a quarter as a percentage, hopefully you're happy with, that I can write it out of 100. Okay, so we multiply top and bottom. So we multiply the denominator by 25 and the numerator by 25. Okay, yeah, to make it an equivalent fraction. So it's 25 hundredths. Okay, and as a percentage, that will equal to 25%, because the word percent means per 100. Okay, for the decimal, well, that would just be 25 divided by 100. Okay, which is equal to 0.25. Okay, think of it as like this, guys. Yeah, so 25.0 divided by 100. Yeah, so decimal point moves 2 places to the left. Okay, so it goes there. It's 0.25. Okay, 0.25 or 250. Okay, 0.25 or 0.250. Okay, putting a 0 at the end actually doesn't actually change my answer yet for that. Okay, that's okay. So my answer goes to 0.25, okay, or 0.25. Okay guys, so it's now your turn to have a go at these questions. So pause the video, try the questions here on these next 2 slides, and then check back with me for your answers, okay? Okay, so answers for these. Question number 1, George rolls a standard fair 6-sided dice. Part A, what's the probability that he rolls an even number? Well, you've got 2, 4, 6, so you've got 3 out of a possible 6 outcomes. Okay, you can think of it as a numbers 1, 2, 3, 4, 5, and 6. Okay, For part B, what's the probability that he rolls an odd number? That'll be 1, 3, and 5. So that'll be 3/6, okay, or equal to a half. Okay, either one's going to be fine. For part C, what's his probability that he rolls a square number? So a square number, remember, is a number that stands by itself, and I get a number. So for example, 1 times 1 is 1. So 1 is a square number. 2 times 2 is 4. So 4 is a square number. 3 times 3 is 9, okay? Square number. Obviously, yeah, I can't obviously go past 9 here because it's a 6-sided dice. So I've got 1, 2, so it's going to be 2/6, okay, or 1/3, okay? Again, yeah, for the purposes of this video, I'm not actually too concerned obviously about simplifying, but yeah, feel free to obviously simplify, yeah, if you feel comfortable. So, okay, remember that's 3/6 simplifies to a half, okay, divide top and bottom by 3, okay, because that's my highest common factor, and then for 2/6, they're both even, so I can divide top and bottom by 2, and I get 1/3, okay, so hopefully you're happy with simplifying it or cancelling down fractions, okay. Question number 2, Jill is selling 20 shirts, 5 blue, 8 white, 3 red, the rest are black. What is the probability of choosing a red shirt? Well, that'll be 3/20, because there are 3 red shirts out of a total possible 20. For part B, what is the probability of choosing a black or a white shirt? So the word or means I'm going to add my numbers together out of 20. So the probability that it's a white shirt is going to be 8/20. The probability is going to be a black shirt. Well, the remaining is going to be black. So 5 plus 8 is 13, plus 3 is going to be 16. So plus 4/20. Okay, and I get the answer of 12/20. Okay, which simplifies to 3/5. Okay, dividing top and bottom by 4. Okay, again, at this stage, I'm not too concerned yet about the simplifying, as long as we are happy about getting the probability answer or answers. Okay, question number 3. Brandon has 3 types of sandwiches. There are 6 ham and cheese, 10 BLTs, and 4 tuna sandwiches. If he picks one at random, what is the probability that he chooses a BLT? That'll be 10 out of a possible 6 plus 10 plus 4, so that'll be 20. So 10/20, which simplifies to 1/2. Divide top and bottom by 10. Okay, or just get rid of a 0. Okay, yeah, so just knock off a 0, yeah. That. For part B, if he picks one at random, what is the probability that he chooses a BLT or ham and a cheese sandwich? So BLT or ham. Okay, so that'd be, so BLT, so that'd be 10/20, or ham, so that's going to be plus 6/20. And then it says here and. Now the word and means that I actually multiply. So I'm going to work this out, and I'm going to multiply by the probability that he gets a cheese sandwich. Okay. So, oh sorry, ham, BLT or, sorry, ham and cheese. Yeah, sorry, I made a mistake here. Sorry, ham and cheese. Yeah. It is going to be together actually. So you found out to ignore me. Sorry, should be 16/20, which simplifies to 4/5, dividing top and bottom by 4. Question number 4. Alicia has a box of newborn puppies, 3 black Labradors, 4 chocolate Labradors, and a golden retriever. She chooses one at random without looking. What is the probability that she chooses a black Labrador? That'll be 3 out of 3 plus 4 plus 1. That'll give me 8. So the answer is 3/8. For part B, what is the probability that she chooses a golden retriever? That'll be 1/8. Okay, or 1/8. 1/8. Okay, for that. Okay, question number 5, guys. So Zakira has a bag of containing 30 red marbles and 10 blue marbles. She reaches in the bag and picks one at random. What's the probability that she picks a red marble? That'll be 30 out of a total possible 30 plus 10, which is going to be 40. So it's 30/40, which simplifies to 3/4. For part B, what is the probability that she grabs a white marble? So that'll obviously be 0 here, so it's 0 out of 30 here, because there are no white marbles there. So again, yeah, so make sure, it is obviously trying to trick you there. Okay, yeah, because, it only has red or blue only. So it has no marbles. So probably to get a white is going to be 0. Okay, yeah, because it's impossible for it to happen. Okay, question number 6. Fraser is at an European roulette wheel. Among the 37 numbers available, there is a green 0. Okay, the rest are red and black. In even amounts, what is the probability of getting a red number? Okay, so there is a green 0, so that means I'm going to knock off 1. So 37 take away 1 is going to be 36, and 36 is shared with red and black evenly. So divide that by 2, and I'm going to have 18. So the probability of getting a red number, that'll be 18/37. Okay, because that's the total number available. For part B, an American roulette wheel has 38 numbers, that is the same as a European wheel, with an addition of a green 00. So a green 00 has the probability of landing on a green number doubled. So on a green 00, well, yes, it has, yes, because obviously 00 means that, it is going to go above, so, or, let's just think about it, So if it has 38 numbers and I've doubled it, well, initially I would have 1/37 on the first one, whereas this one I would have 2/38. Now, are these both equal? Well, they're not, no. So I've times that by 2, but then I've times that by a number less than 2. Okay. So so it's not actually doubled, okay? Because for it to actually double, then it'd have to be 2/37. So the answer is no, actually. So the answer is actually no, okay? Because for it to actually double, then I'm just doubling the numerator and not actually the denominator, okay? Because that simplifies to 1/19th, okay? And that is bigger than this, okay? But it's not actually double it, okay? Because double 1/37 will be 2/37, okay? So hopefully that makes sense. Which style of roulette wheel has a higher probability of landing on a black? Okay, well, it is going to be this one, isn't it? Because obviously I've got 37 outcomes here. So I'm going to have 18/37. Because the second one, the American roulette, actually will be, if it is actually halved, okay, then it would actually be 18 out of 38, which is obviously smaller than 18/37. Okay, think of it as the smaller your denominator of a fraction, the bigger the actual amount is. If that makes sense. Okay, so hopefully it makes sense, guys. Sorry if actually going a bit off topic here. Sorry if actually confusing you, but hopefully it makes sense. Okay. Question number 7. The manager of a football team assigns 20 players a number each 1 to 8. Okay, for defenders, 9 to 16, and for midfielders, 17 to 20 for forwarders. Okay. And 9 to 16 for midfielders and 17 to 20 forwards. A team captain chooses one at random and that player joins the team. Part A. What is the probability that their choice is a midfielder? So that'll be 9 to 16, so that'll be 7 out of 20. Okay, because think of it as player 9, player 10, player 11, player 12, player 13, player 14, player 15, and player 16. Okay. Actually, sorry, it should be 8/20th. It should be 8/20th when you work it out. Actually, when you count it. Okay. Yep, so it's going to be 8/20th, which simplifies to 2/5, dividing top and bottom by 4. For part B, what's the probability that their choice is a forward? So you've got 17, 18, 19, 20. So you've got 4/20th. okay? Because you got player 17, player 18, player 19, player 20, yeah, which I get that, okay? So that's equals to 1/5, okay? So be very careful, guys, here with those questions. Okay, so last set of questions today, yeah, and then that will obviously be the end of today's lesson. So question number 8, okay? Poppy is flying from London to Madrid. She arrives with 9 centre seats, 3 window seats, and 3 aisle seats available. When she reaches the desk, she is given a seat at random. Express the probability that she does not have a centre seat. Okay, so not a centre seat. Well, that'll be 3 plus 3 is going to be 6. That'll be 6 out of 9 plus 3 is 12 plus 3 is going to be 15. So 6/15, which simplifies, so divide top and bottom by 3, and I get 2/5. So 2/5 is a decimal, so 2 divided by 5. Okay, if you're not sure, a little bust up to the side here does no harm. So 2's into 5. Okay, put a decimal point and a 0. 5's into 2 I cannot do. Bring decimal point. Okay, so 9 decimal point there, so bring it up, carry the 2. 5's in 20 go 4 times. So your answer is 0.4 or 0.40. As a percentage, I would do 0.4 multiplied by 100. Okay, so decimal point moves 2 places to the right. So 1, 2, and we get the answer of 40. So it's 40%, guys. Okay, this is question number 9. Okay, Lauren picks a random card from a standard pack of 52, divided equally amongst 4 suits, okay, spades, clubs, hearts, and diamonds. They are then assigned a value of ace, 2 to 10, jack, queen, or king. For part A, what is the probability that she picks a picture card, jack, queen, or king? Well, she can have, okay, so 3, okay, and then I'm going to times it by 4 because, yeah, obviously I've got 4 different, suits, okay, so I'm going to have 12 over 52, okay, divide top and bottom by 4, and we get 3 3/13, okay, so half it and then half it again. Okay, for part B, what's the probability that she picks a spade or chooses a spade? Well, that'll be, that'll obviously be a quarter, so that'll be 13 out of 52, okay, which simplifies to 1/4, okay, dividing top and bottom by 13. Okay, yeah, because obviously a spade, you'll obviously have, ace of spades, and then, 2 to 10, and then jack, queen, or king, so that will give you 13. So 1, and you got 8 there, 9, 10, 11, you got 9 there, 10, 11, 12, 13, okay, hence why, I get that, okay, so think of it divided by 4, okay. Question number 10, part A, the probability of Jane and her partner winning a tennis match is 0.6. What is the probability that they don't win the match? Well, that'll be 1 takeaway 0.6. 1 takeaway 0.6 is equal to 0.4. Okay, again, I can do it as like a column subtraction, if you're not too sure. Think that as 1.0 take away 0.6. Okay, line up decimal. 0 take away 6, I can't do, so I have to borrow. That goes to 0, that goes to 1. 10 take away 6 is 4. Decimal point lines up. 0 take away 0 is going to be 0. I get 0.4. For part B, assuming the probability of winning a match is independent of all other results, what's the probability that they will win 3 games out of 3? So, so I would do so I'll do 0.6 here times 0.6 times 0.6. Okay. Or I can write it here as a fraction if I'm not too sure here. So 0.6 as a fraction is 3/5. We've got 3/5 times 3/5 times 3/5, which gives you, 3 times 3 times 3 is going to be 27. So you're going to get 27 out of 125. So 27 125ths. Okay, total 27 out of 125. Okay, 5 times 5 is 25, times 5 is 125, okay, so 27 125ths for that one. Okay, question number 11. A spinner has a probability of landing on a 1 with a probability of 0.3. What is the probability that if it's spun 3 times, it does not land on 1 or 3 times? Well, the probability that it doesn't land on 1, okay, so this is my notation here for probability, so not on 1, will be 1 take away 0.3, which is 0.7. Yeah, and then obviously if it's 3 spins, then I'm going to do 0.7 times 3, okay? So it does not actually land on 1, okay? And I get 0.21. Okay, if it's spun 3 times, so you do 3 multiplied by 0.7. Sorry, so the answer should be, so the answer should be 2.1. Sorry. Obviously, yeah, in this context here, it doesn't actually make much sense here, but we're assuming that if it's spun 3 times here, it is expected here that 2 of the 3 times here, it will not actually land on 1 based on this probability here, if that makes sense. Okay, so there's a probability of the event not happening times by the number of times here the event occurs. So this is what I call expected frequency or relative frequency. Okay, it's the number of times the event happens multiplied by the probability of the event happening. Okay, or in this case here, multiplied by the probability of the event not happening, which can be 0.7. Okay, so if it's spun 3 times, we would expect that it doesn't land on 1, 2 out of the 3 times here, or 2.1 out of the 3 times. Okay, obviously 2.1 here doesn't actually make sense in this context, but yeah, if we assume here roughly 2 out of the 3 times, it will not land on 1 if it's spun 3 times. Okay, in this context. Okay. Right, guys, so this is our conclusion here. So have we met our outcomes? Yes. Okay, so define probability, yep, so I'm happy with that. Development understanding of how to write probability correctly. Yeah, so using the scale, okay, from ranging from 0 to 1. Calculate probability from example here, so we've done plenty of practice. Yeah, make a note of one thing that you've learned today. So yeah, so make a note actually. Yeah, so the key thing to remember here is probability must always add up to 1. Okay, so that's like a key fact today. So probability must always add up to the number 1. Okay, or add up to 100%. Okay, it can't ever go above 100%. Okay, yeah, to 1, or in brackets 100%. Okay. Right, guys, so that's the end of today's lesson here, looking at probability for functional skills maths for the NCFE course. Okay, hopefully you found it useful. Okay, thank you for obviously tuning in here, and thank you obviously for obviously taking time here to listen and watch the video. Okay, any questions, any queries, let me know. Okay, and I'll see you in the next. Okay, take care, guys. See you soon. Okay, bye.